So I'm going to pull up my whiteboard, and so we can learn about scatter plots. We're going to draw scatter plots. Let's see. Okay. All right. Let me try and draw this scatter plots here. It's not. All right. So let's make them. Okay. Get my. Try this whiteboard again. All right. Okay. Pull you up this way. Maybe that's better. All right. So now we are going to draw scatter plots. Scatter plots. So we are starting with Unit 2 now. Chapter 4, Section 4.1. Number 1, scatter plot number 1. We can have a situation where a line has a positive slope and all the points are on the line. All the points are on the line. And we shall call this one perfect, positive, linear relationship. So in this Unit 2, we are comparing two variables. Variable x, which is called the explanatory variable, or the predictor variable, explanatory variable, and the other variable is the dependent variable, which is y, and the y is the response variable. So we shall call y the response variable in this unit. So whenever you hear response variable, it is y. When you hear explanatory variable or predictor variable, is x. Okay, so this is a situation where the relationship, number 1, the relationship between x and y is perfect positive linear relationship. So now we're going to explain all the letters. Perfect, because all the points are on the line. Positive, because the line has a positive slope. Linear, because the line is a linear function. Relationship, we're talking about relationship. So that is why we shall also call this section bivariate data. Bivariate data. So the data we're working at, there are two of them. So we are actually comparing two of them. So what is the relationship between the two given variables? The x and the y. The x is the explanatory variable, y is the response variable. And both of them, you see, they are choose, so bivariate data. In Unit 1, we had univariate data. So in this Unit 2, we are talking about bivariate data. All right, so the next thing we want to do is go to another kind of scatter plot. So let's get to scatter plot, another one. So I'm going to grab this and move it up a little bit so that I can draw another scatter plot. All right, so scatter plot number two. Number two, I have another straight line, but this time the points are not on the line. The points are actually going to the same direction, but the points are not on the line. So now we're going to describe this, the kind of relationship we have between the explanatory variable x and the response variable y. Okay, so the relationship is high positive high positive linear relationship. So there is a high positive linear relationship between the predictor variable x and the response variable y. Why? Because even though all the points are not on the line, if you eyeball the scatter plot, you see that they are going to the same direction. And the line that will best fit the scatter plot will have a positive slope. So that is why I did not say perfect. I said high positive linear relationship, because the points are not on the line. So high positive linear relationship. Okay, let's describe the third kind of relationship. So I have to draw another L graph. And then this time I have a line with a negative slope. And all the points are on the line. All the points are on the line, a line with a negative slope. So I want to describe the relationship between x and y. So the relationship between x and y is perfect, y perfect. All the points on the line. Perfect, negative, y negative. The line has a negative slope. In other words, as one is increasing, the other one is decreasing. High negative linear relationship. High negative linear relationship. All right. So that's a high negative linear, that's a perfect negative linear relationship. Why perfect? Because all the points are on the line. That's a perfect negative linear relationship because all the points are on the line. Okay, so the next one. So I'm going to pull up the chart so I can draw another one. All right, so now I want to draw the next one. So the next one is 4. The next, now I draw another L graph. And then I want to, this graph has a negative slope again. It's a line with a negative slope. Well, this time all the points are not going to be on the line, but they are all going to a negative direction. all going to negative direction. So the line of best fit for this scatter plot is high, negative. So high negative linear relationship. High negative linear relationship. So that's a high negative linear relationship between the predictor variable and the response variable. And the predictor variable is x, the response variable is y. You see, I'm comparing two variables. High because all the points are not on the line, but you can eyeball the scatter plot and see that the scatter plot has a negative slope. So high negative linear relationship. Okay, so let's draw the fifth kind of relationship. So relationship number 5. In this relationship, the scatter plot are scattered everywhere. Scatter plot are scattered everywhere. On the line of best fit, you cannot detect the line of best fit. So the line is horizontal, almost parallel to x-axis. This is predictor variable, this is the response variable. So you now say that the relationship between, there is no relationship. You cannot identify the relationship. So there is no, it's a no linear relationship. So there is no linear relationship between x and y, x and y. So there is no linear relationship between x and y. All right. So there is something we need. So let's go back and look at all the relationships we talked about. Let's look at the relationships we talked about. So the first relationship is the perfect positive linear relationship when all the points are on the line. That's why we call this bivariate data. We're comparing two variables, the x and y, predictor variable and response variable. Number 2, when all the points are not on the line, but there's a pattern. The pattern is that all the points are going to the same direction. And so we say that there's a high positive linear relationship. Somewhere, if the points are all on the line, but the line of best fit has a negative slope, we say perfect negative linear relationship. So just note that perfect means all the points are on the line. Negative means the line has a negative slope. Linear means it's a linear model. In other words, it's not a quadratic model. It is not a cubic model. It is not a sinusoidal model. It's not a quartic model. So there could be any of them, but we're only doing linear. So that's why linear must be in your definition of a scatter plot. Linear must be in your definition of scatter plots. All right. So we're defining, if you're just coming in, we're defining scatter plots, section 4.1. How many kinds of scatter plots do we have in this, and how can we use it to make a decision? What are we doing? We are comparing two variables. So that's why we called it a bivariate data. bivariate data. Okay, so bivariate data. Okay, so now I am going to grab, okay, so the next one is how else can we define the relationship between two variables? Another way to define relationship between two variables is using the coefficient of correlation. So the coefficient of correlation R can be between -1 is less than or equal to, the coefficient of correlation is less than or equal to 1. If I'm drawing a number line, I can use a number line to denote coefficient of correlation. So this is 1, this is -1, and this is 0. Okay, so note that the coefficient of correlation ranges from -1 to 1. In other words, it cannot be -1.2, neither can it be 1.2. So the range of coefficient of correlation is from -1 to 1. Okay, in other words, when I finish a linear regression calculation, the R can be -0.8 or 0.9. It can be -0.1, or it can be positive 0.9, or it can be positive 0.2. Okay, it can be positive 0.2. All right, so now we are going to actually calculate R, but I want us to go to see, it can actually be calculated with formula. So let's go to our notes unit. Let's see, let's go to our notes. So we have seen the kind of scatter plots we can have. We can have this one is not perfect, but it is high positive linear relationship, high negative linear relationship. This is quadratic, but we are not doing quadratic. This is cubic. This is no relationship. Okay. All right, so we are going to, when I have positive relationship, I will say that there is positive association. So there could be positive association if R is positive. If the slope is negative, then there's a negative association. In other words, the value of R, the strength, shows the strength of relationship. It could be negative or positive. Anyway, how do we calculate R? We can calculate R by solving this equation. If you note this equation, it is x minus x bar over standard deviation, that is the z-score for x column, for each of them multiplied by z-score for y column, multiplied by each other and added together, the sum, then divide by sample size minus 1. You can use your calculator to calculate R. You don't have to use formula, but it's important that you know that this formula, you know what it is. Sometimes formula can look weird, but it's okay. You actually know how to do it. In some classes, you may not actually be allowed to use calculator. So you can be told to find the the coefficient of correlation without calculator. So it's trying to explain what all this means. Xi means the ith observation of the variable. X bar means the mean of the explanatory variable. The S of X means the standard deviation of X. Y means the ith observation of Y. Y bar is the standard deviation. S of X is standard deviation of the Y, and N is the number of individuals in the sample. And you have to use N minus 1. Okay, so we're going to go back and pull up our calculator and actually calculate. First of all, we're going to learn how to put this in our calculator. So first of all, we put this in our calculator. So I'm going to clear, and I'll pull up that worksheet again. And let's go to that data. We have to carefully put in the data. If you make a mistake while putting in the data, no matter how accurate your calculation is, you are wrong already. So you have to carefully put the data in your calculator. So now I'm going to pull my calculator. The first thing to do is go to STAT right here, push to, okay, and edit. When you edit, you see that L1 is empty. So you type in 1 by 1 each value of the explanatory variable. So that is 35, enter, 50, enter, 75, enter, 95, enter, 120, enter, 130, enter, 145, enter, 155, enter, 160, enter, 175, enter, 185, enter, 190, enter. So I have entered the data, and I noticed that I have 12 of them. That is why my calculator is asking me to put in the next one. So you have to actually check everything. I noticed that where I should put in 155, I put in only 15. So you can make a mistake. You can make a mistake. So I'm just going to fix that mistake. That is supposed to be 155, not 115. So as soon as you finish typing in the data, you eyeball it and see that you did make a mistake. So 155 is the correct. So I entered that, and I'm going to look up again and see if there's any other number that doesn't look like what is in the data. Because if your data is wrong, no matter how good your calculation is, it's actually wrong. Because actually what it means is that you changed the question. When your data is wrong, you change the question. All right. So the next one is to put in the Y, which is the response variable. So let's put in the Y. The first one that corresponds to the 35 is 5.88. 5.88 feet. All right. 5.88. Enter. And the next one is 5.99, 5.99, enter. The next one is 6.74, 6.74, enter. The next one is 6.10. 6.10, 6.10, enter. The next one is 7.47, 7.47, enter. The next one is 6.93, 6.93, enter. The next one is 6.42, 6.42, enter. The next one is 7.97, 7.97, enter. The next one is 7.92, 7.92, enter. The next one is 7.62, 7.62, enter. The next one is 6.89, 6.89, enter. The next one is 7.90, 7.90, enter. When I finish, I'll have to eyeball the data. They must be on the same horizontal line. If they are not, then that actually shows that there is a mistake somewhere. We need to fix it. So I'll go to Start. And then the next thing is we're trying to draw a scatter plot. So let's draw a scatter plot. So let me actually second quit before. Second quit. So I'm going to draw a scatter plot now. So I'm going to do second scatter plot. Hit enter. Turn it on. And number. Okay. So arrow down. And then I want to zoom 9. So zoom 9, which is zoom statistics. So this is the scatter plot that I have. What kind of scatter plot is this? Can I describe it as perfect positive or high positive linear relationship or no relationship, or perfect negative or high negative? Which one? You can as well see that it is a perfect, it is high positive linear relationship. But that is not enough. So we need to find the coefficient of correlation that can give us the measure of the strength. The coefficient of correlation gives us the measure of the strength of relationship between the bivariate data, between the X and Y. In this particular case, the bivariate data are the depths at which drilling begins in feet and time to drill 5 feet. So this is the bivariate data, and the X is depth and Y is time. Okay, so we put the data in, we drew a scatter plot, and that is not enough. So the next thing is find the strength. What is the strength of relationship in numbers? What is the measure? The measure is the coefficient of correlation. Can you calculate it? By the time we do a test on the 5th, you should be able to calculate it. So this is the first time we are calculating it, so you might want to pay attention. It's a little bit, it's going to take long a little bit. Alternatively, you use your calculator, you use the formula, but I want to advise you to learn how to use the calculator. Learn how to use the calculator. So now I'm going to start to put a line on this scatter plot. The first thing I want to do is go to mode and ask my mode to give me 3 decimal places, because I don't really want 9 decimal places. So I want 3 decimal places and not 9. I hit enter. Okay, and then I will do second quit. The next thing I want to do is turn diagnostic on. When I turn diagnostic on, my calculator will be able to find the coefficient of correlation. So what is diagnostic? Where can I find it? I will go to second catalog. Whenever anything is in catalog, I have to use the green alphanumeric. So green here. Then I'm looking for this, so I can just find, I'm looking for diagnostic, so diagnostic will be somewhere here. I'm looking for D, so I'm turning diagnostic on. I can actually arrow down and look for D. So looking for diagnostic on, so diagnostic on, see, found it. So I hit enter. And it's asking me, what do you want to do with diagnostic on? I said I want to turn it on, so I turned it on. Okay, then I'm ready to calculate. Before I calculate, I want to zoom 9 again, zoom 9, so I can see the scatter plot. So when I can see the scatter plot, I'll go to STAT, arrow to calc. Well, let's see, the linear regression line x plus b, just like equation of a line, is number 4, and it's also number 8. In number 4, a is the slope, b is the y-intercept, but in number 8, a is the y-intercept and b is the slope. I like to choose number 4, so let me choose number 4. Okay, so I'm going to arrow down. So notice that my L1 is asking me where is the relationship, where do I have explanatory variable is in L1, where do I have response variable is in L2, where do I have frequency? I don't have frequency because I don't need it. Do you want to store your equation? Yes, I want to store my equation in Y1. So I just go to vars. I'm telling my calculator right now that I want to store my equation in Y1. Vars, Y-vars, function Y1. And I'm going to calculate. Hit enter. So notice that I have the value of A, the slope, the value of B, the y-intercept, the value of the coefficient of determination R squared, and the value of R. The value of R is 0.777. So now I can actually write this equation. Alternatively, I can actually click zoom 9 again. If I zoom 9 again, the line will draw on the graph. And if I push trace, the equation will appear on the line. So that equation is y equals 0.012x. So I am going to actually take a picture of that. So I got that because I know it's going to move away far. So now I want to write that equation. And I already know what the equation is y equal to, and A is, according to the equation, is 0.012. 0.012 is not okay. I'm going to pull up my and then I'm going to draw the line here, and yeah, so let's draw the line here and then put in what we are told to put in. So this is the kind of line I had, the line of best fit in that equation, and the kind of scatter plot that I had. So the equation is y equal to, the equation is y equal to 0.012 x plus 5.491. Okay, so this is the equation of the regression line, and I remember that the coefficient of correlation is 0.777. And if I square it, I'll get the r squared. If you square this, then you get 0.777 squared. Okay, so now we can answer the question. The relationship between the predictor variable and the response variable, x and y, has high positive linear relationship. The strength is 77.7%. The strength is 77.7%. The equation is y. We have the equation here. And by the way, it as the y, we can write it as y hat. So whenever you see y hat, you know it is the predicted equation. Whenever you see y hat, is predicted equation. So y equal to x is the kind of equation we chose, plus b, where a is the slope. Whenever the slope is positive, the coefficient of correlation is positive also. When the slope is negative, the coefficient of correlation is negative too. Now we have answered this question. So now we go back to the question. Let's go to that worksheet again and try to explain it. Therefore, the strength of relationship between the depth of drilling and the time to finish is high at 77.7%, almost 78%. So there's a high positive linear relationship between the two variables. And it doesn't really mean that because it is high, that the time, the depth costs the height. A high relationship does not mean causation. Okay, it doesn't mean that x costs y. So it's because of the data given to us, we can make that decision. If we are given another data now, it may be another thing different. So just because of the data we are given, we can make that decision. There's a high positive linear relationship between the predictor variable and the response variable. Okay, so there we go. We are introducing unit 2 today. We started from 4.1. So in this question we just answered, we found out there's a positive linear relationship between the height and the time for. Okay, so let's go back and look at this. So the linear correlation coefficient, which we just found, is R. Or sometimes it's called Pearson product moment. Okay, and then we could have used the formula to calculate this, but that would take the whole class to finish calculating that. All right. Okay, so the next thing you want to do is you can use your calculator. You don't have to use StatCrunch. You don't have to use Excel. It's enough that you use the calculator to do it in the test. And this is what we are doing today. Now, the next thing you want to learn today is the properties of linear correlation coefficient. I know you will not be able to maybe get everything I said today. And we're going to do it again next class. But I'm recording this, so you want to watch this video when you come back or when you join the class. Okay, so just make sure you learn the properties of correlation coefficient R. So these are the properties is listed. The properties of R are listed. It's already in your test, so you must need to know that. So number one, the linear correlation coefficient is always between -1 and 1, inclusive. We said that, that is. And then R is equal to 1, then perfect positive linear relationship. If R is equal to -1, perfect negative linear relationship. The closer R is to +1, the stronger is the evidence of positive association. Okay, number 5, the closer R is to -1, the stronger for negative association. If R is close to 0, no relationship. Okay, number 7, the linear correlation coefficient is a unitless. In other words, it cannot say it is in inches. The linear correlation coefficient is not in inches. It doesn't have a unit, unitless. So the unit of measure for R and Y plays no role. The correlation coefficient is not resistant. Therefore, an observation that does not follow the overall pattern of the data could affect the, that means an outlier can affect the coefficient of correlation. So caution, there's a caution here, linear correlation coefficient close to 0 does not imply that there is no relation. So you can say there's no linear relationship. But if you say no relationship, you don't even know if it is quadratic, you don't know if it is cubic. So that it doesn't have linear relationship doesn't mean no relation. Okay, just no linear relationship. For example, although the scatter plots drawn for in the figure for H indicates that the two variables are related, the linear correlation coefficient is close to 0. So notice that is close to 0. We're talking about this one here, close to 0. Where is that H? But when you do quadratic regression, then you see that it's actually almost perfect. So if it doesn't have a linear relationship, don't say no relationship. That's what it's trying to say. Compute and interpret the linear correlation coefficient. So we already did. This is how you can do it by hand without calculator. And so notice that this is the given X. This is the given Y. This is the z-score for X, z-score for Y, the product of the two z-scores, and then add all of this, add all of them, total, and then we add them, we divide them by sample size minus 1. So it's not even difficult to calculate by hand. All right, so we will continue with this next class. We will do another example, determine the absolute value of the correlation coefficient. Find the critical value in, so we shall actually find the critical value and see what is called product moment correlation. Okay, if the absolute value of the correlation coefficient is greater than the critical value, we say a linear relationship exists between the two. Otherwise, no relationship. So find the critical value in table 2. Okay, and then for the given example, determine the absolute value of them. So we shall actually consider that next class. All right. So explain the difference between correlation and causation. So you need to work on this. So what can cause a high positive relationship? And even though it can a locking variable can cause a high positive relationship, even though they are not related. Locking variable, sometimes you can say outlier. Outlier can cause. All right. So we are going to continue from here next class, and we shall talk about residual. We'll continue and we'll talk about residual next class, and how we can calculate some other things in linear correlation coefficient. So don't forget to read the notes. Read the notes. You need 2 notes. Okay. All right. So if you do have any question, then you will need to ask. But we are going to end today. That's where we're ending today. So ask any question or email me your question